everybody. My name is Yvonne, and I'm going to be talking about sustainable solutions for water purification with magnetic nanoparticles. So, just a brief introduction. Magnetic water is life. Basically, everyone needs water for everything, and it's going to be very complicated to live life without water. And we also need access to clean water, which is a part where most of the world is kind of failing at. And magnetic nanoparticles as emerge as a solution, given leveraging principles of magnetism and susceptibility. The behavior of magnetic materials are being harnessed to work on this critical environmental solution, and it's also like way more economical to use all of these materials, and also um, it's also like good, better for the health aspect of things. And integrating ions that magnetic materials that we are used to, like iron, cobalt, and just setting magnetic principles like using like super paramagnetic materials kind of just makes the system works better in terms of reusability in general. Given the introduction, the content will go through introduction I just went through, and the importance of this solution, magnetic nanoparticles overview, implications in water purification, challenges and future advancements in similar applications, and then the conclusion. The importance of this, of course, the present global challenge of not just water, but also the climate. We care about the environment and we don't want to die of global warming or something like that. So that's a good use of like the importance of this. And then magnetic nanoparticles comes into the rescue to help challenge those concerns that we have relating to access to clean water and also the environmental effects of just having contamination in the air due to industrialization and just waste from production, overproduction that we go through. Then there's also an advantage over the traditional methods that we're used to that we can tell it's not being effective given the state of water still happening today. And then alignment with our course concepts because we got to learn things like magnetostatic and other applications that we'll go through within this presentation in our course, and then just knowing that whatever we learn in class theoretically can be applied in real world is a good feeling. And then tackling the core issues of water and sustainability. And this is just a good image I found that just showed highlighted everything that has to do with the importance. And during time, I won't go through this. Okay, so basically, what are magnetic nanoparticles? They're magnetic materials like iron, cobalt, nickel that we're used to that have very high magnetic properties, significant magnetic properties, and due to their size, they can be controlled by the external magnetic field. And that's basically the definition. And then the super paramagnetic nature of these particles are good because whenever they're introduced into the system, which is an internal field that is ferromagnetic and giving the material like water that is diamagnetic, you're able to separate easily whenever the materials are being interacted with. And the synthesis there are different methods that have been tried for this, which include cold precipitation, thermal decomposition, and biological methods, which we'll see very shortly, given the options. And then surface modification basically works through um, knowing that there are different contaminants and how these contaminants work, and knowing how to introduce this particular paramagnetic, super paramagnetic separatants and magnetic nanoparticles into the system to extract them. And most of it is through absorption. So given the ferromagnetic internal field and then the external ferromagnetic, the internal field. So let's assume carbonous nanoparticles like graphene is an example being introduced there. They have very good absorption properties that observe things like microorganisms and bacteria and other things like diabsorption too. And then the mechanical action involves introducing the super paramagnetic nano micro sorry, magnetic nanoparticles into the water system, and then being able to separate it after with the introduction of the magnetic field. The applications are in water purification, includes a versatile purification agent and heavy, and then using this versatile purification agent, which could range from the biological one or the thermal one, or including there's what I found very fascinating, which is like electrolysis, but then I didn't look too deeply into this for this particular presentation. So different kind of versatile purification agents, introducing them into the system and then absorbing heavy metals, ion removal like lead, which is bad for the health, poisoning, and then organic waste disintegration, exactly like dye absorption and other organic waste and pathogen deactivation as well, which can cause diseases. And this image on this side, this is an example of the plants. I wish I could.
Make that small one.
Okay, so this is an example of the plant based system, which I found very interesting because it has like a plant powder going to a metallic solution and using that for the fabrication of the nano particle that is going to be used for the inversion. And I found that very interesting because it means, I think, just better sustainability applications. It means it could probably dissolve, which is one of the concerns I was showing the challenges. And then this is basically just a model of the flow. So how the water is being passed through, like the carbonaceous system that has been built with like things like graphene. Okay. I'm just yeah. Okay. Now I have to go back.
Make it small, just minimize it,
Okay. I don't know how
like
to.
a little one line.
Okay.
You don't have to, it's fine. Okay.
Great. So this is one of the studies I went through in literature that showed different applications in just the cost effectiveness of it and also the removal efficiency with different nanoparticles. This study, I found it interesting because it just compared a lot of tests that has been done in other articles and see, okay, which one is the most efficient time-wise, cost-wise, and inspection-wise. And a good setup was this article that I also highlighted and how it went through the breakdown with magnetic field intensity and using this computational fluid dynamic to analyze their inputs and outputs, and then also now seeing the reaction. And then this was interesting because this is how it started using copper iron um in the process of extraction of the particles, and then this is the result when looked under a microscope to show like the effectiveness. And most of it are usually in the 90%. So this is the extraction of E. coli, and then also comparing it with well water and S rivers. And you can see just with the higher concentration of like the magnetic nanoparticles, there's like more extraction, which is obvious. And then the removal efficiency is actually very surprising, given the fact that I found earlier articles before this one that had like, say, 60% extraction. And basically just the advantages of water purification, it's a offers rapid targeted and energy efficient solutions, and then the effectiveness is, I think, unmatched, and we should also look into it. And then for research purposes, I just find this super interesting that we could always apply whatever we learn in class and try to find real sustainable solutions towards like real life applications to help people. Challenges is complexity with synthesis. So right now, okay, right now it's kind of very complicated to know exactly what works for each material, and it always differs within what material you're trying to like separate. And the community you find yourself trying to do that particular action. So knowing that complexity and finding balance in that, it kind of like pulls the more years of research before it works. Then environmental concern, the environmental concern is kind of solved with the introduction of magnets. So if it was just nanoparticles, we would worry about the remnant of the nanoparticles within the water system, but with magnetic particles, then it's more like reusable, which kind of and then material stability still under research, regulatory hurdles just with nanotechnology in general. The governments tend to look at that very more um, precisely. And then economic viability, due to the fact that there are already existing ways of water purification, it may be hard to just shift and say, okay, this is better. And it may also now cost more to say we have to change all of these systems that we have in place. And just for future investment, this is just a very good thing to think about for our futures and how it could help other people. But then looking more into it, we could also see more ways which magnetic nanoparticles could also be effective in like drug delivery, biomedical applications, and other environmental conservative factors. And this is just a very cool water system I found. I was like, okay, computational things are happening, so we should technically integrate everything to be computational. And just to giving my conclusion is everything we went through just so that there's hope for the future. And given the core concept, we are able to know how we can apply all of these things in real life. And I love the fact that I got the test results from different articles showing how promising it is. And the concerns seem to be minimal rather than what. And these are my references, and I'm now open for questions.